course, in a Q&A session with Andrew N and his team. So most of questions I can feel that just some people always like to ask that as a beginner, what should I learn? How should I learn efficient and or the learning resource? So one main challenge for the beginner or the learner for the AI, machine learning, deep learning, I think for my expertise and my point of view is deployment. Yes, you can use the Collab. That's just the online service, or you can, I think most of the beginner learner, you can use your local Python environment. But I mean, but if you want to run something with efficient, or you want to use some others tools, you must know something about this stack. So let's focus on this one, this chart first. All these three diagrams I download from NVIDIA, and first we can see this one. GPU, just like Jordan gave us the journey, the NVIDIA GPU, the bottom GPU on your server, maybe not on your server, maybe on your laptop or the workstation. Okay, once you got, maybe you have one GPU or multiple GPUs, and you need your host OS, maybe Linux, maybe Windows. And above that, you will need to install the driver for the GPU. You will install the driver for CUDA. Okay. After that, you can run your example, your Hello World. But if you want to use some great tools, and now they prefer to offer these tools, this toolkit by container. So you need to know what is Docker engine. You need to install Docker, and not only Docker, you need to install the NVIDIA Docker, okay? And then you can try to pull the Docker container by yourself, and with the application, for example, some applications here that just some examples, okay? So that's by yourself. And as individual, you will run maybe one or two, or more, I mean, maybe maximum to 10. But if you not individual, your team, so you need orchestration. So you need maybe the orchestration platform to help you, for example, the Kubernetes, and to orchestrate all your machine learning training jobs with the long time training, batch training, and distributed training, just Jordan just mentioned. So you can see for the deployment, it can be very easy, or it can be very, very difficult. That up to your requirement and your request, what you want to do, right? So just like, because I know some of us tonight audience, there's a high school student, local student, say, welcome again to you. And that reminded me when I was a high school student, that time I tried to learn Java by myself. Then I tried to collect some magazines. But the challenge for me when I open my magazine, I just want to refer or find some funny, interesting examples I can run on my local Windows XP machine, my JDK. But the whole magazine, they will not teach you how to use JDK, or they will not give you some just the game example. They will show you the enterprise. I still remember JBoss, right? WebLogic, Solaris. I totally have no idea what it is, right? What it is, that the totally enterprise. So you see, I can feel there is a gap between the learner, beginner, to the enterprise architecture, because I think just like Jordan, you use for the largest, one of the largest IT company as the enterprise architecture, but there is a gap from the beginner. So my point, AI is still too difficult to use. Even using this screenshot, right? Layer, and I have never mentioned the virtualization. So if we put the virtualization, maybe because we know the VMware, for example, we maybe put another layer, VMware ESXi, and maybe we will use the vGPU. not the one to, not the many to one, maybe the one to many, right? So, I mean, the deployment is still important for everyone. For example, just like A100, I mean, Jordan just mentioned A100. A100 GPU is the latest architecture from NVIDIA. But if just a student who want to use it, yeah, maybe this student can rent the AWS GCP with A100. But there, even the student can rent the GPU A100 from the GCP or AWS. How to run it efficient? That's another topic, good topic. For example, he can choose to use the VM to run the whole VM, or he can choose to use the container. That's just the result totally different because the bill is different, right? If you rent the VM, you need to run the OS, you need to do everything by yourself. But if you want to use the container, maybe 5 minutes, 10 minutes, done. But I mean the environment is set up, done. Then you can try to start your training. So there is still a very long journey. I mean, from the individual, from the beginner to the small business enterprise and to the large enterprise. So that's what I feel. So still very hard to use. But first of all, you need to know the basic function. For example, all the 3 main cores from the deep learning. The first one I think is CS29. That's the famous. That's all the recommendation I can share to some audience here. If you're still a student or the beginner for the machine learning or the deep learning, first the CS229. That's the classic machine learning from the Andrew team, and another two from the deep learning. For myself, I joined and registered all these courses, but I to be frankly, I didn't. I mean, study it piece by piece. I just trust it just the resource. If I have some questions, I will try to search the keyword and try to find the keyword, because it's not easy to learn with not only the computer knowledge, but also, I mean, the linear eligible with the statistics, some other fields, expertise, background knowledge. So that's just my experience. I mean, first I start with the CS229. Then I start with, then the next one is the deep learning specialist. This course, they focus on the deep learning. What is deep learning? Why you need deep learning? Different layer, just like CNN or the BERT model Jordan just mentioned. And after all, they mentioned another topic, and that's the new course from the MOps. MOps is the, I think, very well hot topic. That's because, okay, now you can train your model, you can run your model. But I mean, if you're just a team with 5 members, or you're a team with more than 20 members, that, I mean, the approach totally different, the methodology totally different. So that time we need MLOps. So that's the 2 main course I can recommend. And for myself, roundtable time. So I don't know, for George or Jordan side, do you have anything want to share more, or we can hold the roundtable? George?
Yes. Okay, Jordan, you have something? You can start first.
No, I don't have anything.
Yeah, it's very interesting. Chen mentioned about a learning path. Actually, myself, I was a computer science graduate. I mean, bachelor degree, not a master. Okay? So first, I was thinking about I need to go to get a PhD to be able to do any serious deep learning things. But I think nowadays things are changing so fast, and there are so many online resources and you can follow, and they're very high quality. So I started with Coursera, the machine learning course offered by Andrew Ng, and that was 2013. I just keep following it, keep following it. At the same time, I was working as a software engineer, but finally get the transition from a pure software engineer to become something like a machine learning practitioner. Um, so, I mean, there are so many different paths. It's not necessarily only the way to go through university to academic. There, machine learning and AI is a thing is getting into all domains, all field. It's not only the researchers, engineers, even the product designers. We should all pay attention. We should all just start learning. And I know there are some listeners in here. They're actually high school students and they're interested in this field. And that's really kind of exciting to know. And anyway, just I wish everybody can enjoy it and keep doing it. Okay, that's what I'm saying.
Yeah, that's good topic, good course. So, yeah, so I don't know, any audience, you have any questions, feel free to open your mic and ask us, or we can share something more, or yeah. Sorry, I think the chat function is not working from here. Maybe next time we should switch to another platform, because the YouTube, because some audience from China, and the YouTube is not available there, so that's the reason I prefer to use the Teams. Yeah, great. So just like Jordan, could you share us some? So you talk about the HPC. So for which skill of the customer they need the requirement for the HPC, or there is any criteria, for example, because of their data set very large, so they need HPC, or they have the model is very special, they need HPC.
Yeah. So I think there's three different ways you can think of parallelizing code when it comes to deep learning. There's, first of all, it's the size of the model itself, right? For many GPUs, this model will fit in SRAM. It will be less than 40 megabytes in size, and it will run very fast if you just run it on a GPU. The second level is the data set. Not all data sets, but most data sets and an increasing amount of data sets are larger than 40 megabytes in size. We're talking about gigabytes or even terabytes for some data sets, and that's sometimes depends on the data itself. I have customers, for example, who use cryogenic electron microscopes in the health life sciences research field, and one of those pictures can be 100 gigabytes in size at times. Regular pictures from our new iPhones are like 12 megapixels, right? So megabytes, dozens of megabytes in size at times. So you can see that the size and data can grow pretty quickly. And then the third thing is what we would call the experiment. So let's imagine that I have a relatively small model and I have a relatively small data set, but what I want to do is try many different structures of models or many different hyperparameters for a given model when I'm actually training it. That we would call an experiment, right? So you'd line up a gradient of different values to try for a given hyperparameter or a whole bunch of different hyperparameter combinations, because there's many different things you're going to vary. And so at each of those levels, you can grow. You can grow the size of your model because you want it to be more accurate, and that can exceed like the amount of SRAM or even the amount of HBM memory that's on one of the GPUs itself. You can grow the data set to be so large, or individual files to be so large that one file plus the size of the model will exceed the size of a GPU memory or even a single system's memory. And then you can grow the amount of experiments you want to try in one launch of a training run. And that's either because an individual is trying to try a bunch of different options for a model, or because you're trying to have a whole team collaborate and use one system, or one person is going to kick off one job, let it run for a few hours, and then go start working on something else, and they want to have availability there. So all of those different levels, whether you're growing the size of the model, the size of the data set, or the amount of experiments you're running, can lead to the need for HPC. We see this probably most commonly in organizations that are doing natural language processing, which would be anybody who has, it's very common in financial services, anybody who has, wants to do sentiment analysis for people leaving comments on a website, they want to detect fraud, that sort of thing. Natural language processing, those models are growing very, very large. Data set sizes in computer vision are certainly the largest outside of some of the more scientific data shapes. But if you're trying to, do image classification, object detection, semantic segmentation, those sorts of things, those data sets can grow to be really, really large, even if the models don't grow at the same rate that a model in natural language might grow. So those would be the two big ones, and hopefully everybody understands that difference in parallelization. I always struggle with that word.
Yeah, and just for HPC, that is not a new technology. Even just like 10 years ago, we had already had the HPC.
Right.
Why it's hot again? By your opinion, why it's hot again? I mean, especially now everyone's talking about HPC, mainly because of the deep learning and the high demand of the distributed training and with the high performance of GPU.
Yeah. So definitely, I kind of talked about how people just starting with AI could grow in size and then suddenly discover they have an HPC problem, which somebody who's been doing operational weather calculations or computational fluid dynamics or finite element analysis or computational chemistry or genome sequencing or bioinformatics or any of these scientific things that an HPC cluster would have supported in the past, that's only one class of people working on AI, right? There's many AI practitioners or people who are now ML practitioners who are coming from a background of doing HPC effectively. And there's also a whole bunch of people who are coming from a background of doing data analytics or data science without machine learning. And so we see three different entry points for people discovering they have an HPC problem. It's somebody who just started with AI and the size of their network is growing, or the amount of networks they need to build and manage and deploy is growing. It's people who are data analysts. They understand Hadoop and Spark and the whole Apache ecosystem there. They're starting to do machine learning, typically with structured data and databases, right? Data warehouses. And then there's the other entry point, which is that traditional HPC world where somebody was doing Monte Carlo simulation for the bank and is now going to try using a neural network, or was doing genome sequencing for a whole genome and is now going to do exome or targeted genome sequencing, and they're going to start trying to process it with a machine learning model of some sort. So there's definitely three different ways in which we see people start discovering this is an HPC problem. And of those three, the HPC community that was doing a lot of modeling and simulation, they're the ones with the biggest clusters today. You know, people working for the Department of Energy in the US, for example. And so they kind of define the terms, and then everybody else follows in a way. But it's certainly not to say that all AI practitioners are HPC experienced people. Like many customers that I talk to, I work with, are not coming from an HPC background.
Yeah, so I mean, if they want to use HPC, first they need the maturity should reach the HPC level first. If they cannot reach the HPC level, for example, just some three dimension you mentioned, and the HPC maybe they just need they don't need the HPC. I mean, just the high performance of the GPU or something. That's enough. Okay.
Yeah,
So
I don't think.
Yeah.
I don't think that building a big cluster is necessary for everybody, and hopefully I didn't say that today. I just definitely think that thinking about these problems the way HPC people have been thinking about them for a long time is really useful.
Okay, thank you. So there is another question for George. So you just demoed the TensorFlow.js, and one question for you. So the TensorFlow.js, that JavaScript, because the one explanation for the JS that for the focus on the client side, and can we understand that the TensorFlow, not TensorFlow.js, the Python TensorFlow, running on the server or running on the Jupyter or running on everywhere. So that's for the server side. So the whole workflow process maybe from the server side, CS or the backend will use the TensorFlow, and from the edge side, from the client side, to use the Tensor.js. So that's their design. Why we need the Tensor.js?
So there are different use cases, right? TensorFlow.js is not the only JavaScript library, or it's only the edge kind of edge side of deep learning things. There are many situations, as what I mentioned, say data privacies, especially when you do some kind of a facial recognition and things. Sometimes you don't want the data being sending to somewhere else, right? And using TensorFlow.js, these kind of things, another benefit is you can have your model running in your web browser without connections. You don't have to have a round trip to the backend. There are all kind of different use cases and scenarios. If you do real-time things or you do batch processings, you have always different decisions and considerations. And as what Jordan mentioned about big clusters, that is definitely for those training with kind of a billions of parameters, and you're never going to think even about TensorFlow.js. But you are something like you're talking about a game, or you do a smart application built into your web applications, and that's something TensorFlow.js can fit in. It's just a tool, and for different requirements, the different functionalities, the different objective, you choose different tools and technologies. The one thing to say is it's called TensorFlow.js, and it's having a very similar API with TensorFlow itself. And actually, you can use TensorFlow to train a model and save it, and then load it in TensorFlow.js. As far as they have the same network architecture, network design, you can use the weight. You train it from a big server. The thing is, there's still constraints, as what I said, they are serving different purpose. A web browser especially something you're running in your phone, is very limited in computer resource. You're not going to have a huge model and run in a TensorFlow.js. You sometimes need to trim it. You sacrifice your accuracy to make them much smaller size. I didn't mention in my talk is everything has a trade-off and a compromise. When you're running a model in edge devices, people probably don't pay attention. There's some kind of a cost as you have to import your model, and that's called model import, and the model warm-up, and the inference time. All these things is quite unique and different than the things you are running from the backend. And so hope that answered questions.
Yeah, very good. And so, by your point, I mean, your demo still can be running on any browser, for example, iPhone or iPad or any browser, website browser, right?
Yeah, it didn't at the beginning. It runs well
Yeah.
on a desktop browser, but when I test with my iPhone, it's just super slow. The FPS is probably 5 or something. So I have to sacrifice, I have to trim the input, the video size, and I have to lower the process time by just to take shortcut of the tracking algorithms. And I have to adjust the model itself. There are several models for hand detections, even just for TensorFlow.js. Actually, I was using the standard way, and they're using in their code, and that one didn't perform well on mobile phones. So I tried the WebGL one, and try the WebAssembly ones, and yeah. So I spent a lot of time to adjust the configuration to choose the right model to make it running in my iPhone. That's what I'm saying. It's always for application engineer, for researchers, or for the infrastructure MLOps guy. They have always perspective to the machine learning and AI things, right?
Yeah. So for the JS, I mean, for the PC side, can we use any GPU, local GPU, to accelerate the browser running or the performance?
That's a great question, actually. If you run TensorFlow.js, actually you can use any kind of GPU because there is an abstraction layer, the WebGL. WebGL is providing API for browser to do the 2D and 3D rendering. That's help our TensorFlow models to do the training and inference. If you run TensorFlow.js, you have to have the correct drivers installed, that CUDA version and things.
Yeah.
This is one of the beauty I like about TensorFlow.js. You don't have to do any setup. You don't need to do any installations. It's there available for you. Of course, their trade-off is much slower. Their data says for GPU kind of a model, just only rely on GPU, TensorFlow.js 2 times slower than the TensorFlow.js. I think it's not too bad because JavaScript is famous in the speed. It's low speed, right? Okay.
Okay, thank you, George and Jordan. So for the great topic and a great session tonight. So all the record will be uploaded to the YouTube channel, and I mean, if you can share the slides, I'm so glad to share to the audience, and wish to see all the audience, our new friend, our older friend, next month. Okay, thank you.